This is an audio-visual presentation on variation. We will consider the types of variation, and the types we are going to consider are: we have the direct variation, we have the inverse variation, we have the joint variation, and we have the partial variation. Now, we are going to consider all these types one after the other. Now, we start with the direct variation. When two variables x and y are related in such a way that when y increases, there is a corresponding increase in x, then we say there is a direct variation between x and y and vice versa. Now, what we mean is that when x and y are directly related to each other, it means that as x increases, y also increases, and as x decreases, y also decreases. When it happens like that, then we say that there is a direct variation between x and y. Now, if y varies directly as x, mathematically, we have y varies directly as x, where this is the variation sign. Now, this implies that y is equal to kx, where k is the constant of proportionality. So when we introduce our constant of proportionality, the variation sign now changes to equal to. And so if y varies directly as x, then it implies that y is equal to kx, where k is the constant of proportionality. Where k is the constant of proportionality. Now, assuming that y is equal to 2x, that means that k is equal to 2 in this case. The constant of proportionality is equal to 2. So y is equal to 2x. Now, when x equals 1, that means that wherever we see x in the equation y equals 2x, we have to substitute 1. And so when x equals 1, y will be equal to 2 times 1, and the result is 2. When x equals 2, y will be equal to 2 times 2, and the result is 4. When x equals 3, y will be equal to 2 times 3, and the result is 6. When x equals 4, y will be equal to 2 times 4, and the result is 8. When x equals 5, y will be equal to 2 times 5, and the result is 10. When x equals 6, y will be equal to 2 times 6, and the result is 12. Now, let's first look at the red arrows pointing vertically downwards. When you look at the trend of the x values, we can see that there is an increase in x from 1 to 6. That is, x increases from 1 to 6 downwards. At the same time, y also increases from 2 to 12. So as x increases from 1 to 6, y also increases from 2 to 12. Now let's look at the blue arrows. Also, as x decreases from 6 to 1, y also decreases from 12 to 2. This means that there is a direct variation between x and y. Why? Because as x increases from 1 to 6, y also increases from 2 to 12. And as x decreases from 6 to 1, y also decreases from 12 to 2. That means that there is a direct variation between x and y. Now let's take a look at this example of a direct variation. P varies directly as the cube root of y. If p equals 25, when q equals 125, find the value of q when p equals 15. Now from the question, it's a direct variation question. And the question says that P varies directly as the cube root of Y. If P equals 25 when Q equals 125, find the value of Q when P is equal to 15. Now the first condition given is that P is equal to 25 when Q equals 125, and this is the condition we are going to use to find our constant of proportionality. Now let's look at how to solve this problem. Solution. From the question, P varies directly as the cube root of Y. So we have our P varying as the cube root of Y, and this is how we write the cube root of Y. So P varies directly as the cube root of Y. Now when we introduce the constant of proportionality K, the variation sign now changes to equal to. So we have P equals K times the cube root of Y. Now from the question, we were told that when P equals 25, Q equals 125. So wherever we see P, we substitute 25. And wherever we see Q, we substitute 125 in the equation P equals K times the cube root of Q. Now in doing that, by substitution, we have 25 is equal to K times the cube root of 125, because Q equals 125 and P equals 25. Now when you take the cube root of 125, the answer is 5. And when you multiply 5 by K, K times 5 is equal to 5K. So 5K is equal to 25 on the left hand side. Now because we are solving for K, we divide the right hand side by 5. And we divide the left hand side also by 5. When we divide 5K by K by 5, when we divide 5K by 5, we have K. And this is equal to, when we divide 25 by 5, 25 divided by 5 is equal to 5. This means that the value of K, that is the constant of proportionality, is equal to 5. So we now substitute K equals 5. And therefore P is equal to, instead of K times the cube root of Y, because K has now given us 5, we have P equals 5 times the cube root of Q. So P equals 5 times the cube root of Q. Now from P equals 5 times the cube root of Q, we are asked to solve for Q when P is equal to 15. So from P is equal to 5 times the cube root of Q, we have to make Q the subject, since we are asked to solve for Q. So making Q the subject, we have to take cube of both sides. That is, we have to raise the left hand side to the exponent 3, and we have to raise the right hand side also to the exponent 3. Why are you doing that? Because of the cube root of Q. We are making Q the subject, and Q is under the cube root. That means that before we can eliminate the cube root, we have to raise the term to an exponent 3. Now on the left hand side, we have P cube is equal to, on the right hand side we have 5, the cube root of Q, all raised to the power 3. This exponent 3 is affecting both 5 and the cube root of Q. So on the left hand side, P raised to the power 3, we have P cube. This is equal to, because 3 is also affecting 5, we have 5 raised to the power 3 times, now the cube root of Q raised to the power 3. The 3 will now cancel the cube root, and so we are left with Q. Now P cube is equal to 5Q times Q. So we have to divide the right hand side by 5Q. And 5 cube is the same as 125. So we divide the right hand side by 5 cube, or 125. And whatever we do to the right hand side, we make sure we do the same thing to the left hand side. And so when we divide the right hand side by 125, we are left with Q. And that is the Q we have here. When we divide the left hand side by 125, we have P cube divided by 125. What is happening is that the right has now become the left, and the left has now become the right. That is the left hand side. The right hand side becomes the left hand side, and the left hand side becomes the right hand side, which is still the same. So Q is equal to P cube divided by 125. Now when P equals 15, Q equals 15 cube divided by 125. Why? because we have q equals p cubed over 125, and we are given p to be 15. That means that we substitute 15 wherever we see p. So instead of p cubed, we have 15 cubed, and that's how come we have 15 cubed divided by 125. 15 cubed is equal to 3,375. So we divide it by 125, and 3,375 divided by 125 is equal to 27. This means that q is equal to 27 when p is equal to 15. Now we consider inverse variation. This is when two variables are connected in such a way that when one quantity increases in magnitude, there is a corresponding decrease in the other quantity. That is, when one quantity increases, the other quantity decreases, and when one quantity decreases, the other quantity also increases. Now, if y is inversely proportional to x, then it means that y varies as 1 over x. That is inverse variation. When we introduce the constant of proportionality k, the variation sign now changes to equal to. So we have y equals k times 1 over x, and k times 1 over x will give us k over x, because k times 1 is k divided by the x. So y is equal to kx, where k is the constant of proportionality. Now, assuming y is equal to 2 over x, when x equals 1, it means that wherever we see x, we substitute 1. And in doing that, when x equals 1, y will be equal to 2 over 1. That is 2. When x equals 2, y will be equal to 2 over 2, and the answer is 1. When x equals 3, y will be equal to 2 over 3, and the answer is 0.6667. When x equals 4, the answer y will be equal to 2 over 4, which is equal to 1 over 2, and the answer is 0.5. Now, let's look at the trend or the behavior or the values of x and y. First, looking at the red arrows pointing vertically downwards, we can see that as x increases from 1 to 4, y is decreasing from 2 to 0.5. Now, looking at the blue arrows, we can see that as x decreases from 4 to 1, y increases from 0.5 to 2. This means that there is an inverse variation between y and x. Now, let's look at this example of an inverse variation. P varies inversely as the square root of q. If q equals 36, when p equals 5, express p in terms of q. Hence, determine the value of q for which p equals 7.5. So there is an inverse variation between p and q. That is, p varies inversely as the square root of q. Now let's look at the solution. From the question, p varies inversely as the square root of q. This implies that p varies inversely. That means that p varies as 1 over the square root of q. That's an inverse variation. When we introduce the constant of proportionality k, we have to change our variation sign to equal to. And so it implies that p equals k times 1 over the root of q. K times 1 equals k. So p is now equal to k over the root of q. Now, from the question, when q equals 36, p is equal to 5. That means that wherever you see p, we have to put 5. And wherever you see q, we have to substitute it by 36. So by substitution, we have 5 is equal to k over the root of 36. Now, to solve for k, we have to cross multiply. Take note that the whole number 5 is the same as 5 over 1. And 5 over 1 is the same as 5. That is why the 1 cannot be seen. So by cross multiplying, we multiply k by the 1, and k times the 1 is equal to k. This is equal to 5 times the root of 36. When we take the square root of 36, the answer is 6. So we have 6 times 5. That is 5 times 6, and the answer is 30. So the constant of proportionality k is equal to 30. Now the relation between p and q is therefore given by p is equal to, instead of k over the root of q, Now K has given us 30. So it's given by P equals 30 over the root of Q. It's given by P equals 30 over the root of Q. Now P equals 30 over the root of Q. We are asked to find Q when P is equal to 7.5. Now 7.5 is a mixed fraction, so we need to convert this to an improper fraction. How do we convert? We multiply the denominator of the fraction by the whole number. So 2 times 7 equals 14. Then we add the answer to the numerator, that is 1. So 14 plus 1 equals 15. Then we divide it by the denominator of the fraction. We divide the answer by the denominator of the fraction, that is 15 over 2. This means that 7 whole number 1 over 2 is equal to 15 over 2. Now P is now equal to 15 over 2. P is now equal to 15 over 2. So by substitution, we have 15 over 2 on the left hand side because P is now 15 over 2. So we have 15 over 2 is equal to 30 over the root of Q. To solve for Q, we have to cross multiply before we continue. So by cross multiplication, we have 15 times the root of Q is equal to 2 times 30. That is 15 will multiply the root of Q is equal to 2 will also multiply 30. And that is how come we have 15 times the root of Q equals 2 times 30. Now, because we are solving for Q, we first divide both sides by 15. So we divide the left hand side by 15. And we divide the right hand side also by 15. Now when we divide the left hand side by 15, 15 will cancel 15. So we are left with the root of Q on the left hand side. 2 times 30 is equal to 60. So we have 60 divided by 15. And 60 divided by 15 is equal to 4. That is 15 goes into 60 4 times. So root Q is equal to 4. Because we are solving for Q, we have to square both sides in order to eliminate the square root. So squaring the left hand side, we have the root of Q all square. And squaring 4, we have 4 square. When we square 4, the answer is 16. And the square root of Q all square, the 2 will cancel the square root and we are left with Q. This means that Q is equal to 16. Q is equal to 16. Now joint variation. Joint variation has to do with relations in which one variable depends on more other variables. I repeat, joint variation has to do with relations in which one variable depends on 2 or more other variables. When one variable depends on 2 or more other variables, then we say we have a joint variation between the variables. Now example, the heat H produced by an electric current. The heat H produced by an electric current varies directly as the square of the applied voltage. So there is a direct variation between the heat and the voltage. Now let's continue. And inversely as the resistance R. So there is an inverse variation between the heat and the resistance R of the wire. Now let's continue. A voltage of 540 volts applied to a wire of resistance 40 ohms produce 1458 joules of heat. Find A, an expression between H, V and R. B, the resistance that will produce 588 joules of heat when the voltage is 420. Now, from the question, when the voltage is 540, the resistance is 40 ohms, and the heat produced is 1458. So this condition, 540, 40 and 1458, will enable us to calculate for the constant of proportionality before we can proceed from there. Now let's look at how best we can solve this problem. From the question, we know that H varies directly as the square of the voltage. So we have H varies directly as the square of the voltage. And inversely, that is why it's over R. And inversely as the resistance. So H varies directly as the square of V and inversely as the resistance. Now when we introduce our constant of proportionality, our variation sign now also changes to equal to. So we have H equals K times V square over R. Now K times V square will give us KV square divided by the R. So H is equal to KV square over R. Now from the question, when the voltage is 540, the resistance equals 40 and the heat equals 1458. So by substitution, wherever we see V, we substitute it by 540. Wherever we see R, we substitute it by 40. And wherever we see H, that is the heat, we substitute it by 1458. And in doing that, we have 1458 is equal to K times 540 square divided by 40. Now we cross multiply. So 40 multiplies 1458. So we have 1458 times 40 on the left hand side is equal to 540 square is equal to 291600 times K. So it is 291600 K. Now because we are solving for K, we have to divide both sides by 291600. So we divide the right hand side by 291600 and we divide the left hand side by 291600. When we divide the right hand side by 291600, we are left with K, and that is K we have on the left hand side. When we divide the left hand side by 291600, we have 1458 times 40 divided by 291600, and this is equal to 1 over 5. That means that the constant of proportionality K is equal to 1 over 5. 1 over 5. So from H equals KV square over R. Now we've gotten K to be 1 over 5. So by substitution, we have H is equal to V square divided by 5R. V square divided by 5R is equal to H. Now, if H is equal to V square over 5R, when the heat is equal to 588 and the voltage is equal to 420, how do we find the resistance? It's a matter of substitution. Wherever we see H, we substitute it by 588, and wherever we see V, we substitute it by 420. And so by substitution, we have 588 equals 420 square divided by 5R. Now we cross multiply. So 588 times 5R on the left hand side is equal to 420 square will also be equal to 176400. That is 176,400. Now we are solving for R. So we divide the left hand side by 588 times 5. Because it's multiplying, we can divide it by 588 times 5. And we divide the right hand side also by 588 times 5. And in doing that, when we divide the left hand side by 588 times 5, we are left with R. And when we divide the right hand side by 588 times 5, we have 176400 divided by 588 times 5. Now 588 times 5 is equal to 2940. So 176400 divided by 2940 is equal to 60. So the resistance is equal to 60 ohms, because that is the unit of the resistance. We have 60 ohms. 60 ohms. Now let's consider the partial variation. Let us consider the partial variation. This type of variation involves relations which are connected by two or more variables and consist of parts which are sums of other variations. They consist of parts which are sums of other variations. Now, if U is partly constant, it means that U is equal to K1. That's the first constant of proportionality. And at the same time, partly varies as V. That will be the sum of the second variation, that is plus K2V, where K2 is also a constant of variation. So if u is partly constant, that is u is equal to the first constant of proportionality, k1, and u also partly varies as v, so plus k2v. So u is equal to k1 plus k2v. Also, if x is partly constant, that means that x is equal to k1, that is the first constant of proportionality, and partly varies inversely, because it's inversely is plus k2 over y. So x will be equal to k1 plus k2 over y. Now, if p varies partly as q, that is p varies partly as q, that means that p is equal to k1q, and partly as the square of r as v, then we have plus k2r squared, that is the square of r. Now, let's look at the question. Partial variation. The size of each interior angle, theta degrees, of a regular polygon is partly constant and partly varies inversely as the number of sides n of the polygon. The interior angle of a regular polygon with 36 sides is 170 degrees, and when the number of sides is 48, each interior angle is 172.5. Determine the relation between theta and n. Then b, find n when theta is equal to 156. So from the question, when the number of sides is 36, the interior angle is 170 degrees, and when the number of sides is 48, the interior angle is now 172.5 degrees. This means that for partial variation, we have two simultaneous equations to solve. Now let's look at how we can solve this problem. From the question, theta is partly constant, and so theta is equal to k1, and partly varies, so we add it to the sum of the second variation coming, and so partly varies inversely as n. That's why it's plus k2 over n, because it's inverse variation. So theta is equal to k1 plus k2 over n. So we have our two constants of proportionalities. So where k1 and k2 are constant to be determined. Now, when the number of sides equals 36, the angle is 170 degrees. So wherever we see theta, we substitute it by 170. And wherever we see n, we substitute it by 36. And in doing that, we have 170 is equal to k1 plus k2 over 36. Now we multiply through by 36 to simplify the equation. And so 36 by 170 is equal to 6,120. This is equal to 36 times k1 is equal to 36 k1. And k2 over 36 times 36 is equal to k2. Let this be our equation 1. Also from the question, when n equals 48, theta equals 172.5 degrees. This implies that 172.5 is equal to k1 plus k2 over 48. Now we multiply through by 48 to simplify this equation. And so 48 times 172.5 will give us 8,280. This is equal to 48 times k1 will also give us 48 k1. And k2 over 48 times 48 will give us k2. Let this be our equation 2. These are the two equations that we are going to solve simultaneously for the two constants of proportionality, k1 and k2. Now, 6120 equals 36 k1 plus k2 is our equation 1. And 8280 equals 48 k1 plus k2 is our equation 2. Now, we subtract one equation from the other. Using the elimination approach, we are eliminating the constant k2. So because they have the same coefficient and they carry the same sign, we subtract one equation from the other. So we subtract equation 1 from equation 2. So we are subtracting the whole of equation 1 from equation 2. So when we subtract 6120 from 8280, we have 2160. That is 2160. When we subtract 36 from 48, we are left with 12. But because of the K1, we have 12 K1. When we subtract K2 from K2, the answer is 0. So we have 2160 is equal to 12 K1. We need to find K1. So we divide the right hand side by 12. And we divide the left hand side by 12. When we divide the right hand side by 12, we are left with K1. And when we divide the left hand side by 12, we are left with 2160 divided by 12. That is how come we have K1 is equal to 2160 divided by 12. And the answer is 180. That means that K1, that is the first constant of proportionality, is equal to 180. Now, from equation 1, 6120 is equal to 36 K1 plus K2. Now, K1 has given us 180. So, by substitution, we have 6120 is equal to 36 times 180 plus K2. And 36 times 180 equals 6,480. And that becomes minus 6,480 on the left hand side is equal to our K2. Now K2 will now be equal to 6120 minus 6,480, and when we subtract 6,480 from 6,120, the answer is minus 360. That is how come we have K2 equals minus 360. So by substitution, we have theta is equal to 180 minus 360 divided by n, minus 360 divided by n. This is because K1 gave us 180 and K2 gave us minus 360. So by substitution into the equation, we have theta equals 180 minus 360 divided by n. Now, theta equals 180 minus 360 divided by n. Now B, we are asked to find the number of sides when the angle is 156. So this is just a matter of substitution. Wherever we see theta, we substitute it by 156. And in doing that, we have, instead of theta, we have 156 is equal to 180 minus 360 over n. So we multiply through by n. So n times 156 will give us 156n. This is equal to n times 180 will give us 180n. And 360 divided by n times n will give us 360. And that is how come we are left with minus 360. Now, let's group the variables on the right hand side and the constant on the left hand side. So minus 360 on the right hand side becomes 360 on the left hand side. We have 180 on the right hand side. 156n on the left hand side becomes minus 156n on the right hand side. So this can also be written as 180n minus 156n on the left hand side is equal to 360 on the right hand side. So 180n minus 156n equals 24n. So 24n is equal to 360. Now we are dividing both sides by 24 so that we can make n the subject. Dividing the left by 24, we are left with n. Dividing the right by 24, we are left with 360 by 24, and the answer is 15. That means that the number of sides is 15 when the angle is equal to 156 degrees. This is the end of our presentation on variation.